Physical science, electric current. Today we are going to learn about the electric circuit, series and parallel connections. When we switch on this electric circuit can be open or closed to cut off current to flow through circuit. More than one device is connected in a single path is called series connection of resistance. So this is a series connection. So three bulbs are connected in a single path to battery with a conductor. So when these three lights are connected in a single path one by one, the bulbs are connected with a conductor to battery. When we can open the circuit, then the current passes from the battery to light. Okay, so these lights are getting glow. Then measure the three bulbs resistance connected in series and noted the values are R1, R2, R3 and measure the potential differences of each bulb as a V1, V2 and V3. The sum of the potential difference of the bulb is equal to the potential difference across the combination of the resistors. So V is equal to V1 plus V2 plus V3 is 1. So here we observe the three bulbs are getting light. Then we measure the three bulbs potential difference and the resistance also measured as a R1, R2, R3 and potential difference V1, V2, V3. So the current passes through these lights are constant. Equivalent resistance of a series connections. So here the lights are indicated by these resistance. So potential difference sources like this V1, V2, V3 and the resistance are R1, R2, R3. I is constant. Equivalent resistance of series connection. Equivalent resistance. So first we take in resistance as a R1, R2, R3. Next one, totaling the three resistance R1, R2, R3 taken as a equivalent resistance. Bulbs are shows as a resistors. So here bulbs are shows as a resistors. With the symbols and resistors are connected in path equal to I. So here three resistance are different, but here the equivalent resistance as a equivalent resistance are taken here. According to the Ohm's law, so already we learned about the principle of Ohm's law. V is equal to IR. V is equal to IR. It is a Ohm's law. So here we taken the V1 is equal to IR1 and V2 is equal to IR2. V3 is equal to IR3. Why here three bulbs has a V1, V2, V3 and three bulbs has a R1, R2, R3. Okay, so V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. According to this principle, V is equal to IR, this is a Ohm's law. Current drawn by each resistance is equal to current drawn by combination of resistor is called equivalent resistance. Okay, so each resistance means R1, R2, R3. So these are equal to equivalent resistance. So current drawn by combination of resistor is called equivalent resistance. So V is equal to I equal resistance. According to this equivalent resistor, V is equal to I equivalent resistance. So when these values are substituted, formula 1, so V is equal to V1 plus V2 plus V3. This is the first equation. So V means I equivalent resistance is equal to IR1 plus IR2 plus IR3. So equivalent resistance is equal to R1, R2, R3. So I is cancelled. So we get the equivalent resistance is equal to R1, R2, R3. It means sum of individual resistance is equal to equivalent resistance. Sum of individual resistance means IR1 plus IR2 plus IR3. So this sum of the individual resistance is equal to equivalent resistance. Equivalent resistance this one. Combination of resistors is called the equivalent resistance. So sum of the individual resistance is equal to equivalent resistors. So this series of connections are not used in our home because of when one device is spoiled, then all another devices in our home also spoiled. So the connection, series connection not used in the connection of devices in our homes. In our homes we used the parallel connections of resistance. Why? Because one device is spoiled, it is enough for that device, not another device is present in our houses. So suppose fan is damaged, so TV is working on. So only one device getting damaged, enough for that device only. Other devices is worked as it is. So now we learn about the parallel connection of resistors. Bulbs are connected in a parallel. So bulbs are connected as a parallel. Parallel means one by one. Bulbs are connected. It is called parallel connections. Potential difference at each bulb is same. So here in the series the current is a same, but here potential difference of each bulb is same. I1, I2, I3 currents flowing through R1, R2, R3 resistors are equal. So here also the bulbs has a resistance and shows as a R1, R2, R3. R1, R2, R3 and potential difference as a V1, V2, V3. Resistors are equal. We can write I is equal to I1 plus I2 plus I3. Equivalent resistance of a parallel connection. So here also we take the individual resistors are equal to equivalent resistance. So here also the bulbs connected to a battery by using wires, and here when the current passes through conductors, the current is split into some another directions. First direction this one I1, and second direction this one, and third direction this directions. According to the Ohm's law, I1 is equal to V by R1 and I2 is equal to V by R2. I3 is equal to V by R3. So here we show the current passes through these two bulbs, and the potential difference V1, V2, V3, and the resistance is a R1, R2, R3. So here we, according to Ohm's law, I1 is equal to V by R1, I2 is equal to V by R2, I3 is equal to V by R3. And here in the series connection, we, according to Ohm's law, V is equal to IR taken, and in the parallel series, I is equal to V by R1. I2 is equal to V by R2. I3 is equal to V by 3. Equivalent resistance. Equivalent resistors is a I is equal V by equivalent resistance. So here also 3 bulbs shown as a 3 resistors in a parallel direction, and the current passes through these conductors I1, I2, I3, and the resistors R1, R2, R3. Okay. So these individual resistors shown as the equivalent resistors. So equivalent resistance means this equivalent resistor is I is equal to V by equivalent resistance. Substituting the values I1, I2, I3 in equation 1, we get V by equivalent resistance is equal to V by R1 plus V by R2 plus V by R3. Why? Because the Ohm's law is I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. So these values, when we substituting, so then we get V by equivalent resistance is equal to V by R1, V plus V by R2 plus V by R3. So the two resistors R1, R2 are connected in a parallel. So 1 by equivalent resistance is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then the equivalent resistance is equal to 1 by R1 plus 1 by R2. Then equivalent resistance is called R1 into R2 by R1 plus R2. So this is a formula for the parallel connection of the resistors. Okay, thank you.